Hello everyone, welcome from John here, the Chief Wingnut at WingNut Laboratories. We've had quite a bit of progress over the last 10 days, 2 weeks on the WingNut project. Here, what do we have here so far? There's been a change in the direction. I've had to drop the Bluetooth sensors from the equation. From the program due to various reasons, but that has meant a benefit of sorts in that I've reduced the wingtip sensor portion that will go on the wingtip of the wingsuit quite a bit in size and weight. It's quite light now. So in here there's a pitot tube right here, and then there is the differential air pressure sensor. Is located underneath this Gorilla Tape, as well as an angle sensor, basically something that measures the angle of the wingtip. I could have one installed on the on my body somewhere, or on the helmet, I guess. But for now, that's just going to go on the. I'll have one on the wingtip. So this is Cat5 cable that I have now connected to it. So I'll run it up the arm of the wingsuit. They'll just be a little bit exposed at the tip of the wingsuit, but it'll be covered by tape. But so that all runs up here now to the helmet. And what do we have going on here? Well, this LCD will actually be on the front of the helmet, and I hope to have it mounted in such a place that I can read the airspeed. That'll be something that gets modified over time. But right now it's powered on. I just don't have it outputting the information, because I recently acquired this little back plate here that simplifies the number of wires. Strange as it may seem, but there's only 4 wires now coming from the LCD in place of what would have been, 11 or something like that. So that needs to be recoded. Here's the FlySight GPS that we had before, and under it I've just mounted the 5, I guess it's 5 connectors there, which contain the I2C connections. I2C is a method of communicating that only requires 4 wires from a sensor to the module that's coordinating everything. Basically, there's power, there's ground, and then there's the data line and a clock line. So it's quite simple to utilize, and that was initially the reason why I went to Bluetooth, because it wasn't designed. I2C was not designed for use over wires of any length. It was designed for just on the printed circuit board on the chip, basically. But I've seemed to have no problems. I'm up to a meter in length between the wingtip and the helmet unit, and I'm getting good data back. Over here we have the GPS. There is one, of course, in the FlySight, and this is the same module of GPS, basically. But I needed to use it right now for just a timestamp, essentially a real-time clock that I can timestamp my files. And eventually I'll use it for probably computing other things, outputting other information. But right now it's just strictly for timestamp, because I do have all the information that FlySight's recording as well that I can download and analyze the data. Then we have right here the little guy next to the GPS right here. This is an SD card adapter, and I'll just I'll take the SD card out of there. It is storing all the data at a sampling rate of approximately every 2 or 3 seconds. All the information that the sensors are outputting. And then let's see, what do we have over here? We have, actually I'll come over to the side. This is the second of the airspeed sensors. This is the older one, and it's still going to be an accurate sensor, I believe. So this will be hooked up to a chin-mounted pitot tube that'll be over here. And I want to compare the 2 sensor readings to see, are they comparable? You know, they won't be able to calibrate each other, but if they're both reading about the same, well, that tells me that that either location is good for a pitot tube, either the helmet or on the wingtip. So it'll be good to compare those 2 readings. Then I have up here, which I hope is going to be fairly in fairly undisturbed airflow is a static air pressure sensor and a temperature sensor, and that's going to be useful, necessary information that for me to calculate things like true airspeed, which I can utilize then to analyze the performance. There's the LCD. And then lastly, what's coordinating it all? Right now it's getting powered, and this is called the Arduino. And I'll eventually go to a much more clean setup with all the wires. Right now I just soldered these tonight in a very quick, hacky kind of manner. But anyway, it's all hooked up and it's working. So it's getting power from the computer, from the PC. And that's also allowing me to see some very limited data. But in the biggest thing that it does is it coordinates all these sensors. All the sensors head from the I2C connections down here back onto one set of wires, heads to a couple of these pins here, and then all that information is then sent out over some wires over here to the SD card. So that's basically where I am on the project. Now, when I first turn on the unit, I've just got an error there because well, here let's see what it does actually. Okay, I'll get this out of the way. I'm gonna put the SD card back into the case. Where is it right now? A little awkward in the placing, but anyway, that's what I have going on. Okay, so let's see. I'll bring up, get ready for the serial monitor. So I'm going to reset the Arduino, hit the reset button in there. That resets the process, and then I'll go up here. And then it takes a bit. It's going to run through the GPS signals and wait for it to get and there's the timestamp. So 02737. And that's in UTC. So here we are, it's 9:07 Eastern Standard Time. So what does that put us at? That's 21 to 02. So 0207 and 37 seconds UTC. So they're 5 hours ahead of us. And it's a CSV file, just the same as the FlySight is. So that's the only information I do get from the window here, the monitor. But then I can take out the SD card. Put it in an adapter here. Hold on. Okay, I have it in the adapter card here now, and then I'm going to place it in the computer. And then when I get there's the file right now that we just said 02737. So if I click on that, what's in there? Let's see, we have the time 02740, so that's when the first data, and 40 seconds, then 42 seconds, 45, 48, as you can see, and so on. So it's mostly every 3 seconds, I guess, is recording the data. Airspeed is currently 0. The next was the angle. Well, it's sitting at 6 degrees, and that's because this was sitting here stationary here, and I'm not sure. I'm not sure if I have it set up for roll or pitch. I do need to do a slight modification, but that's what it was doing, sitting there. And if you see here, so it's showing between 6 and 7, 6, 7, and 5. So there's slight little variations going on depending upon, did I move it around slightly. Then there is the temperature. Oh, I guess I got that backwards. I have to change the header. So pressure is next, and that is in pascals, I guess. In millibars would be 983 millibars. And then the temperature in degrees Celsius, 27. I guess I like it warm in here. So that's all that's going on. Anyway, that's what's going on right now here at the Wingsuit Laboratories, the WingNut Laboratories. As you can see, my place is living room is basically a collection of wingsuit paraphernalia, and then various boxes from Amazon, eBay, and mostly from China, I guess. And here is my soldering and hot wax and drilling and filing, hacking center. Anyway, that's all that's going on here. I'm off to work tomorrow for a 27-hour layover in Orlando. Hopefully the progress will continue when I get back, but thanks very much for watching. Hope you learned something.